Intro to understanding equations. Law of conservation of mass, law of conservation of energies means however much you start with, you should end with. It can't be created or destroyed. You can't create something from nothing. You can't vaporize things so that they completely vanish from existence. So what does that mean? In terms of chemical equation, if you have 2 atoms of hydrogen before the reaction, you must have 2 atoms of hydrogen after the reaction. Got it. So if we look at the chemical equation of the formation of water, we have, here's how to read this. So here's what the numbers mean. The subscripts tell you how many atoms of that element you have, and then the coefficients tell you how many of that molecule or compound you have with that many atoms in it. So how to read 2H2 is, think of it this way. You have 2 H2s. So if it helps, as I recommend for some people, put parentheses around the compounds. To figure out the total number of atoms of that element, you do what you do with Miss Love Tech, and you distribute. So the number of hydrogen atoms total you would have with 2 H2s is you'd have 2 times 2, okay, which is 4, of course. So you'd have 4 hydrogen atoms total. Okay, a way to visualize it, here they are. Look, so here is 1 H2, and then here we have another. There's our second H2 right here. Hydrogen, hydrogen. So you have 2 H2s, and they have to be present after the reaction as well because mass is conserved. So you see this H2 right there. Where did it go? What did it become? Here it is right here, there and there. Okay, there are your 2 hydrogens. And then these 2 are right here, 1 and 2. So notice we didn't lose any. Okay, there are 2 H2s, another 2 H2s. And there they are right there. We didn't lose any, didn't gain any. What are these? This is an O2. This is a diatomic oxygen. Okay, you have 1 of those, 1 O2. All right, and there's your invisible coefficient, number 1. Well, there's our 1 O2. So you have 2 oxygen atoms bound together to make 1 diatomic oxygen molecule. Where do they go? Right here after the reaction. So in the reaction, you have 1 of the oxygens binding with 1 of the diatomic hydrogen molecules. Okay, those combine, and then this is what you get in the end. Okay, you have 2 H2Os. All right, stop it.